Good evening, Professor. This is my MMIC first assignment, first homework assignment, and as as the homework was assignment was about to search paper regarding MMIC and just review that paper. I have find this paper. The paper title is High Frequency GAN Hemet for HEMTS for RF MMIC application. What was the abstract of this paper was they had find a key challenges and technical breakthrough that uh, leads to the development of high scale GAN HEMT having FT greater than 4000 gigahertz and Fmax greater than 550 gigahertz and corresponding IC process. Highly scaled GAN device have 5 times higher breakdown voltage than transistor, which having a similar high frequency RF power gain. Other semiconductor system also SI, GE in gas, other things, and power. The first generation of Ka band MMIC were built using highly scaled GAN device, represent a significant improvement in PAE over a value reported other semiconductor technology. At this frequency band, Ka band MMIC built in lower frequency GAN nodes, and in the next generation 28 gigahertz, 39 gigahertz, and high frequency 5G mobile bands, uh, uh, GAN transistor has excellent for MMIC, and because of this, it has been greatly extend a battery life in mobile handset and their superior PAE compared to competing semiconductor technology. Next was the introduction of this paper. GAN HEMT as most powerful and most efficient solid state RF source, 1 gigahertz to 100 gigahertz portion of the electromagnetic spectrum. Now, as you can see in this figure, I have mentioned the this figure is a comparison of power. Left hand side is of power and left hand side is of power and right hand side is of efficiency of RF and pass using again and various other transistor technology. Trending line are based on data available for this open literature, and uh, superior RF power performance GAN MMIC results a unique combination of large semiconductor band gap and high electron velocity, large two-dimensional electron gas, 2D EG sheet density, and that included AIG GAN heterojunction interface. uh, uh, I am just going to explain the previous these figures in detail in this slide. Uh, in this GAN helmet is a further aided as a external thermal characteristics that substrate from choice of deposition of high performance GAN HEMT MMIC, and this performance data or lower cost SI substrate which has roughly 1 upon 3 on of the thermal conductivity of SiC, and GAN on SiC MMIC do not quite match the power of PAE performance. For GAN, MMIC on Si substrate. Uh, in this outperform perform MMIC is best competing technology in power and efficiency, had FT of 90 gigahertz and F max of 200 gigahertz, and the combination of this is 94 gigahertz and efficiency of MMIC PA that built using again HEMT deposit having FT-FMX value inferior to those corresponding NP. It provides outstanding potential, and this device have high frequency application, provide motivation to nitrate next generation technology program, the which goals to extend the frequency of range of device by factor over three state of the art, and W band GN-MIC device, and it is a very attractive high frequency gain HEMTs for manufacturers of high frequency. Operating frequency is greater than 50 gigahertz RF power amplify of a high linearity Roberts low noise amplifier, and very efficiency operating at low frequency is below 50 gigahertz, and high transistor are attractive for construction of very high efficiency PES. And next is it also the operating frequency enables the implementation of high efficiency switching mode wave of thermal to device, high device gain at higher order harmonic of operating frequency. Next, as you can this is three generation of highly scaled GaN transistor developed under NEX next effort of HRL. FT FMX, as you can see in this figure, also traditional scale T gate, self-aligned symmetric, self-aligned asymmetric, and which correspond common source of fourth curves overlaid with FT middle, you can see in this, and FX is in bottom, measured at measuring bias point. I will explain this figure detail in next slide. As I said, the first generation of HLR was aggressively scaled, and electron beam literally three tie layers, and simultaneously scaling the device gate length, that is 40 nm, and the first generation device have FT 160 gigahertz, FMX is 38 gigahertz, and breakthrough voltage was exit to 40 voltage, and the source drain separation of 1:1.1 meters, and in T3 GaN process HLR was greater than 7% improvement in MMIC PAE, W band 84 gigahertz over MMIC fabricated, and the second and the third generation device is T symmetric and T asymmetric. The last this the middle one and the last right one is 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 subtractive self-gain gate fabrication process that enables a significant reduction. uh, Spacing LG value is 20 nm and LSD is 100 nm. This subtract the fabrication process and was used to demonstrate 105 stage ED mode ring oscillator contain over 1000 resistor. And the second generation device is T4 GaN HEMT, simultaneously achieved 450 gigahertz. FT is greater than 450 gigahertz and F max is greater than 440 gigahertz. And yes, um, it is a self-aligned asymmetric process that enables the realization of asymmetric device, a short source of gate LSG spacing, a longer LGD spacing. And geometry improves that breakdown voltage. Fmax slightly degrades device FT, and third generation simultaneously achieved FT that is greater than 320 gigahertz, Fmax greater than 580 gigahertz, and breakdown was lower, 15 volt. And in this uh, T4A device is a next gen MMIC node. High max and the breakthrough voltage are more relevant, and merit was resonate circuit and low noise figure of 1 dB measured and frequency of 37 gigahertz of first MMIC build. To compare this NF lowest reported values, best competing technologies has been reported in this paper. First generation MMICPS that utilize the latest generation of highly scaled T4AG HMNTs. And next was K band T4 GN MMICPA. In this K band MMIC T4 process to illustrate the performance improvement that can be achieved higher device by taking advantage and Harmonic achieve high efficiency by switching mode wave from at device output. And single stage MMIC was realized in 50 mm substrate thickness, microstrip topology, power combining 4 into 37.5 unit cells, and non-linear device model was extracted by T4 GaN device and measured frequency. You can see in this figure also. It has clearly mentions that measure and simulate small signals gain and simulated current voltage waveform at plane of 4 is to 37.5 unit meter building block of this high efficiency of MMIC PA. Now this is the power in power out characteristic. 4 is to 4 is to 37.5 GaN MMIC, which measure the third figure of frequency 32 gigahertz and equistrain bias of voltage 2 volt left port and V volt middle port, and power and frequency of MMIC is VDS to V pin equal to 13 dBm. In this requisite drain current are adjust of high peak PAE performance. Gain expansion P in out measured peak PAE of MMIC was 59%. Both drain bases associated P out of 21.2 dBm and 24.3 dBm and associate gain of 8.9 dB and measured peak drain efficiency of MMIC was 71% to 69 respect. Drain bias was 2 voltage and 3 voltage. After accounting this 0.3 insertion loss of output, combining network and estimate drain, which the device has 75% to 73, and the voltage was 2 and 3. And next, this is the comparison of TA fourth generation and GAN MMIC was published K band, as I said in before. K band I have explained in previous slide, and high voltage GAN MET load pull data and PAE of T4 GAN MMIC is superior to available published data. In this, the peak power density MMIC of 40 mm is roughly factor of 10 lower than SOA and lower frequency, but comparable to values reported gas MHET is P and PHEMT MMIC operating this frequency ranges. To measure output of T4 MMIC, 21.2 dB, 24.3 dB meets output power requirement of for MMIC handset of for next generation, that is 28 gigahertz and 39 gigahertz higher frequency 5G mobile bands, and total output power is T4 PA is 24 or 22 dB, sorry, 20, it is 22 dB lower than the highest power K band, and lower frequency node is superior to available published for both GN 21% higher PA less that best reported 15% gas PA has been reported in this paper. Next, I'm going to conclude this paper. In this, the technology breakthrough that leads to development of high-scale GAN HMT having FT greater than 400 gigahertz and Fmax greater than 550 gigahertz. This is highly scaled device. K-band switching mode MMIC PA having PAE 59%, DE is 71%, and GAN HEMT D is 75% at a frequency of 32 gigahertz, and the reported PE is the best knowledge 15% point higher than the best value reported at K band MMIC, and 5G mobile band has MMIC PA suggested that highly scaled GAN has a highly attractive component of headset and set of mmw 28 to 39 gigahertz and higher, and it has greatly extended a battery lifetime in mobile handset due to superior PAE compared to competing semiconductor technology. Yes, thank you for this assignment.